Are we alone in the universe? Those involved in the search for extraterrestrial life have increasingly shared the view that mankind may not be ready for contact with an alien civilization. It becomes obvious the moment we put dreams and imagination aside and delve into the scientific approach. Not only can the search for intelligent civilizations be fruitless, but it may also lead to opening a door that we are not ready to walk through. What mysteries actually hide behind the cosmic silence? And why do we put so much effort into coming into contact with extraterrestrial beings, knowing that we may never achieve this goal? After spending years exploring the possibilities of coming into contact with extraterrestrial beings, scientists have come to surprising conclusions. Let's imagine that an alien civilization is at the same level of technological advancement as us, and their spacecraft fly at the same speeds as ours. It turns out that intelligent life with this level of advancement needs less than 1 billion years to spread across a galaxy the same size as ours. Just look at how quickly the galaxy would have been inhabited by any civilization of this caliber. But if that were the case, why are we not seeing this lively galaxy around us? To answer this question, we'll need to take a look at the Kardashev scale. The majority of modern scientists use this scale to measure the potential ability of living organisms to colonize the surrounding space, and, subsequently, the possibility of contact with other life forms. This scale gives its own answer as to why we are not seeing this image of populated space all around us. Nikolai Kardashev proposed measuring a civilization's level of technological advancement based on how efficiently it uses its energy resources. According to this scale, a Type 1 civilization can learn to utilize all of the energy that it is able to harvest on its home planet, radiating from its parent star. This type of civilization is most likely ready for interplanetary travel and, at some point down the line, will be able to colonize its entire star system. For context, we only use about 73% of the planet's energy potential, whereas the amount of energy we learn to harness from the Sun is less than 0.1%. It turns out we're still Type 0. According to this scale, civilizations that have reached the status of Type 2 are capable of capturing energy not only on their home planet, but also any energy they could harness within their entire star system, or, at the very least, they're close to doing so. In their search for this type of civilization, scientists are on the lookout for a Dyson sphere, a hypothetical artificial structure that would allow a civilization to harness all of its star's energy. These civilizations would be capable of interstellar travel. They would have actively colonized their own galaxy and possibly moved on to colonizing the surrounding regions, allowing them to keep increasing the amount of energy they could use. Type 3 civilizations are able to harness the energy of neighboring star systems, control the energy of their entire galaxy, or even the entire universe. These civilizations are able not only to control this energy, but possibly even reshape entire worlds. There's a simple reason why communicating with a Type 1 civilization is problematic. Upon calculating the capacity at which we can transmit and receive signals in space, we find that the maximum visibility of Earth's energy activity, radio signals, lasers, and electrical activity, is very limited. We can only be seen or heard from a distance of about 4 light years. The noise we create could only be detected by our closest neighbors, assuming they have reached the same level of development. A Type 2 civilization would be able to hear us from much farther away. They would also be able to ensure they remain unnoticed, either because of the great distance or because they wish to keep it that way. After 60 years of transmitting various signals and scanning the skies in search of artificial signals, we still haven't found anything. We remain unheard. The Fermi paradox, often referred to as the Great Silence, was first raised by the legendary physicist Enrico Fermi. Speaking with his colleagues, he posed a seemingly simple question: where are the aliens, and why haven't they come to visit us? However, when you consider our civilization's current level of development, the answer may seem rather obvious. Why would they? The logistics required for interstellar travel are only available to civilizations that have reached at least Type 2, and, in their eyes, we may simply not be worth the effort. What person in their right mind would try to communicate with ants? How would an ant even recognize that someone was trying to communicate with it? After all, in terms of our technological development compared to such a civilization, we would be akin to highly developed ants that have taken over an entire planet, while still making inefficient use of its potential. Other civilizations that, like us, haven't yet reached Type 1 would most likely remain confined to their own planets and star systems. It's simply unrealistic to expect visitors from civilizations at that stage. It's possible that, at this very moment, they're working through the same problems we are: starvation, competition for resources, and conflicts ranging from minor disputes to major wars over territory. So it appears that Type 1 civilizations would simply have more immediate concerns to deal with. But is it possible that someone has already overcome those challenges and launched themselves into space? The data presented by scientists suggests that we may, in fact, have a surprisingly large number of neighbors. As we lift our gaze toward the cloudless night sky, we can imagine just how many potentially inhabited planets might exist. What we see in the sky represents only about 1% of our own galaxy, the Milky Way. Even if only 1% of those worlds are inhabited by conscious life, that would amount to around 100,000 intelligent civilizations within our galaxy alone. And yet, they all remain silent. There are a vast number of proposed solutions to the Fermi paradox. In fact, there are around 100 scientific theories that attempt to explain this cosmic silence. Let's examine some of the most interesting ones. One possibility is that there are no Type 2 or Type 3 civilizations because they simply don't exist. Scientific analysis suggests that there could be thousands of civilizations in our galaxy alone. Therefore, many scientists presume that there must be a factor preventing civilizations from progressing beyond a certain stage of development. This hypothetical obstacle is known as the Great Filter. The theory suggests that, after reaching a certain level of development, every civilization encounters a barrier that is impossible to overcome. Scientists still don't know what this Great Filter might actually be. The possibilities are limited only by our imagination. It could range from artificial intelligence wiping out advanced organic life to various forms of global catastrophe or extinction events. The most unfortunate aspect of this theory is that, if it's true, humanity faces three possible futures. According to the first scenario, we are a unique life form that has already managed to overcome the Great Filter. That would mean reaching our current level of progress is extraordinarily difficult, and the chances of it happening elsewhere are extremely low. In this case, the cosmic silence would be explained by the fact that the overwhelming majority of civilizations failed to overcome the Great Filter. We simply have nobody to make contact with. The second scenario suggests that we just happen to be the first among our neighbors to reach this level of advancement. This would imply that the conditions necessary for the emergence of intelligent life were established only relatively recently, and we happen to become the pioneers of that process. In this case, we simply found ourselves in the right place at the right time to become one of the first highly intelligent civilizations. It would also mean we still have plenty of time to progress toward becoming a Type 2 and eventually a Type 3 civilization. According to this view, there is little hope for contact because we are advancing faster than any other known form of organic life since the Big Bang. The third scenario presented by scientists is far more pessimistic. It suggests that if we were not the first civilization to reach this stage of development, then the Great Filter still lies ahead of us. According to this idea, life evolves normally until it reaches a certain stage, which may be exactly where humanity stands today. Whatever or whoever the Great Filter is, it presents an obstacle that prevents civilizations from ever advancing to Type 1 status. And it's unlikely that humanity would somehow be the lone exception. Those who support this third hypothesis believe that the cosmic silence is actually bad news for us. After all, the discovery of complex life on Mars, one of Jupiter's moons, or anywhere else would imply that the Great Filter is probably still waiting in our future. There's also an opposing viewpoint. According to this perspective, Type 2 and Type 3 civilizations really do exist. We simply haven't encountered them for a reason. This argument is based largely on the fact that our search is still extremely limited. After all, we're searching for signals that have traveled only about 100 light-years, which represents only a tiny fraction of the Milky Way galaxy. Some of the most interesting theories based on this idea suggest that the galaxy has already been colonized. To those hypothetical colonizers, our solar system may simply lie within an unimportant, sparsely populated region. A useful historical comparison is the colonization of North America. Many Native American communities living in remote regions learned about the arrival of Europeans only decades after they had already reached the continent. It's also possible that advanced activity is already taking place around our own solar system. We may simply be too technologically primitive to recognize the signals. Or perhaps we're searching in entirely the wrong way. That would be like trying to communicate over the internet using Morse code. It's equally possible that alien minds differ so fundamentally from our own that our attempts to establish contact appear to them as nothing more than meaningless noise. Another fascinating explanation is the zoo hypothesis. It proposes that we are actually surrounded by a densely populated galaxy. In this scenario, Earth is something like a protected wildlife reserve. We are observed, but direct contact is deliberately avoided so that our civilization can develop naturally. Still, every attempt to explain the Fermi paradox eventually reaches the same conclusion. We still know remarkably little about the universe, and we have not yet advanced to the level necessary to answer these questions. But that doesn't mean our search for intelligent life has stopped. Humanity certainly isn't standing still, waiting for someone else to make the first move. There are currently at least 2 major projects that have spent decades searching for extraterrestrial life and attempting to establish contact. These projects are SETI, Search for Extraterrestrial Intelligence, and METI, Messaging Extraterrestrial Intelligence. The work of both projects is based on the Drake equation, a mathematical formula that attempts to estimate the number and, more importantly, the potential locations of intelligent civilizations within our galaxy. The next step is to use this information to reach out. According to some estimates based on the equation, our galaxy could host anywhere between 8 and 2,900 intelligent civilizations. As science has advanced and our knowledge of the Milky Way has improved, these estimates have become increasingly refined. Some studies even suggest that there could realistically be around 36 technologically advanced civilizations coexisting with us in our galaxy. The SETI project began in 1984, initially focusing on scanning our cosmic neighborhood for artificial radio signals from potential extraterrestrial civilizations. However, no confirmed signals have ever been detected. Today, one of the greatest hopes lies with the European Space Agency's Gaia mission. Gaia is mapping the precise positions and motions of nearly 2 billion stars, allowing scientists to identify the most promising planetary systems in unprecedented detail. Because of this, SETI has evolved from making rough estimates about potential targets to conducting highly focused searches of individual star systems. Thanks to advances in technology, every signal we transmit can now be directed toward the systems considered most likely to host intelligent life. Will we ever receive a reply? The answer is both yes and no. Some of the star systems we've targeted are so distant that even if an intelligent civilization responded immediately, their message wouldn't reach Earth for more than 3,600 years. MITI also plays an important role. Rather than only listening, it actively attempts to send messages to potential extraterrestrial civilizations. Humanity has already made at least 8 deliberate attempts to communicate with the cosmos. 2 of the most famous are the golden records aboard the Voyager spacecraft, along with similar plaques carried by the Pioneer probes. The remaining messages have been transmitted by powerful radio signals directed toward nearby stars, including Gliese 581. In total, humanity has carried out roughly 40 radio transmission sessions aimed at potential extraterrestrial civilizations. We're unlikely to hear a response ourselves, but it's entirely possible that our descendants will. To sum up the results of our exploration, one thing seems clear. The silence of the universe may be perfectly normal. It's possible that humanity simply hasn't evolved enough to communicate with whatever intelligence may exist around us. Or perhaps the cosmos itself isn't yet ready for that encounter. Which of these possibilities seems most likely? Are we truly a unique species? Or has the galaxy already been colonized by civilizations far more advanced than our own? We may be closer than ever to discovering the answers. But are we ready for first contact?